Hello, let's have a look at the adapter pattern. And this is the book that I mentioned in a previous video, which is Dive into Design Patterns by Alexander Shvets from refactoring.guru. And I'm looking at the adapter pattern, and we're adapting a car to a railway track. No, we're not. Adapter is a structural design pattern. So you've got behavioral, creational, and structural. This is a structural design pattern that allows objects with incompatible interfaces to collaborate, also known as a wrapper. I don't think it's exactly the same as a wrapper, but in Python, for instance, it's similar, but not exactly the same thing. Imagine you're creating a stock market monitoring app. The app downloads stock data from multiple sources in XML format, then displays nice looking charts. At some point, you decide to improve the app by integrating a smart third-party analytics library, but there's a catch. The analytics library only works with JSON. Okay. You can't use the analytics library as is because it expects data in format that's incompatible with your app. The example I'm going to do is going to be with a legacy printer and a new printer, so to speak. So that's what you can see on the main screen. So I'm just going through the concept here. The solution is create an adapter, convert the interface of one object so another object can understand it. So I'm not going to give away all of Alexander's intellectual property rights. This is the book if you want it. It's about $15.99 in UK money, probably $15 in US, I would guess. 15. I think it's half price at the moment. So yeah, hop over to refactoring.guru. If you missed my first video, this is called Dive into Design Patterns by Alexander Shvets. There he is. So let's have a look. I've just started doing this, and yeah, let's just make it a bit bigger. Hopefully the dark color's okay for you to see. So we've got a trait, and trait is printer, and it does print function. We've got a struct called legacy printer, and then we've got an impl for the legacy printer. And the impl just does a function called old print, and it prints a message. So these first three things, the trait, struct, and the impl, are nothing that you wouldn't already be familiar with in Rust. Good. Right, next we've got this, which is the adapter. So we want to store an instance of the legacy printer inside the adapter to properly adapt its behavior to the printer interface. So we've got the old printer, we want to make it use the new printer effect. So far so good. Just looking at my notes. Right. Next we want to do an impl legacy printer adapter. And this is where we need to create the legacy printer adapter instance. I think that's right. New. And then this returns legacy printer adapter, curly braces, and then we return this. So whatever we pass in, we're returning, but we're returning it wrapped effectively, isn't it? So legacy printer. That's happy. I'll just run my shortcut to allow unused. Right. So this allows us to store a legacy printer inside the adapter, and then we pass in a variable which is of type legacy printer. Ah, that's wrong. Or is it? That should just be. I've got type hints turned on. Sometimes if you have type hints turned on, that can just be legacy printer, can't it? That's it. Yeah. If I put on toggle inlay hints. There we go. Right. So we've got everything here now except for the import of the printer for our legacy printer adapter. Already written trait, which is top. So this will be the last part. So if you're watching and you're thinking, what the hell is all this about? What I'll do is I'll put this in a gist and then I'll put it in a description. So we're implementing the printer, which is basically the new printer for legacy printer adapter. We can't implement it directly on the legacy printer. We need to implement it on the legacy printer adapter. I must admit, this is not the easiest design pattern that I've tried to learn. I'd say the builder pattern is very intuitive. Factory pattern, yeah, but this is yeah, slightly less intuitive. So we're just going to pass in the string that we want to print, because after all, that's the whole point. And then we need to do self.legacy printer. Then once we've got the old printer object, we can do old print. And then the message is, that's just a kind of we pass in the text. And I've got an error there. Why is that? FM print, ampersand self text. Did my trait, I don't think in my trait, I didn't put message up here. Text, string, ampersand string. Right, let's go back down. That's all good. If I compile that, it's happy. And now we need to actually use it. So we're going to create a legacy printer. Obviously what you put here doesn't need to match what you've got above, name-wise. Sorry, I sneezed. So that's created the legacy printer, which is of type, it's a legacy printer. Now we do let adapter call legacy printer adapter, and we use the new function, and it knows legacy. That's the benefit of using the same variable names, because then you can just accept the automatic suggestion. Use struct literal syntax instead. Oh, did I do the I did. Yeah, if you use empty curly braces there, you'll need to use empty curly braces when you actually use it. So let's sorted that. And then use the adapter as a printer. So I'm referring to my notes a lot here. So this will work, and I'll provide you with the gist of this. But obviously, either get a textbook example and unpick it, unravel it, or make your own version of this. So we've created a legacy printer, and then using the legacy printer object, we've used it with an adapter, passed it into the adapter, and then the adapter allows us to use the new printer. Hello world. So let's go back to Alexander's example, and we'll just look at the rest of the document. The adapters can not only convert data into various formats, but can also help objects with different interfaces collaborate. The adapter gets an interface compatible with one of the existing objects. Using this interface, the existing object can safely call the adapter's methods. So the adapter's method is print, because the legacy printer adapter we implemented print because we did import printer for legacy printer adapter. I don't know if this is the best example. If anyone can comment or point me in the direction of a more easy to, it just seems we've got legacy, we've got lots of legacy and we've got lots of printer and lots of adapters here. I don't know if this is the best way to learn this, but let's have a look at the code example. This will be pseudocode. The implementation uses object composition principle. So we're using composition rather than inheritance. Let's see if I can find the pseudocode and let's have a look. Okay, this is great. I love his examples. They really simplify. The example of the adapter pattern is based on the classic conflict between square pegs and round holes. So you can put a round peg in a round hole, but what if you want to put a square peg in a round hole? You use a square peg adapter. So this is using classes and methods here, which not entirely convertible to Rust, but if you go to refactoring.guru, you'll see there's, if you scroll down on each pattern, there will be an option to get the Rust code. So this is the reason to use it. Use the adapter class when you want to use some existing class, but its interface isn't compatible with the rest of your code. The adapter pattern lets you create middle layer class that serves as translator between your code and a legacy class. How to implement. make sure you have at least 2 classes with incompatible interfaces. Obviously, the equivalent to a class in Rust being a struct plus an import. Pros and cons. Yeah, the overall complexity of the code increases. That's true. So some pros. The open and close principle is something I still just need to really get clear in my head. You can introduce new types of adapters into the program without breaking the existing client code as long as they work with the adapters through the client interface. Okay. Right, I'm going to quit while I'm ahead here because otherwise we're going to start getting into other patterns as well. So yeah, just a big up to Alexander for doing this book. And I shall put this code in a gist, whatever it's called, GitHub. Feel free to copy it, modify it, break it, all the usual. Thumbs up, subscribe, like, and all that nonsense for the YouTube algorithms. So just remember the bits there. You've got a trait, a struct, an import. So that's just normal. Then we did this, which was we created a struct, which was the adapter. Then we attached a function to the adapter. So we pass in the legacy printer object, and then we return an instance of the adapter with the original object inside it, which then allows us to use the new style trait or the new style function on it. It makes sense when you look at it, but if you locked me in a room and made me type it from memory, I'd probably fall over. But therein lies the task of repetition. Probably type this from scratch, you ought to be able to do this, and then just remember the steps here. So you create the struct for the adapter, create the import for the adapter. I'll probably remember this by tomorrow, but I might forget that by tomorrow. So I think half the battle of learning stuff is to be honest with yourself about what it is that you might forget. So what I'll probably do is I'll delete this section and I'll come back in an hour or two and then I'll try and type this block. And yeah, and then later on this evening I'll probably delete this and try and redo it from scratch. And obviously you don't want to, in machine learning it's called overfitting. I mentioned this in the previous video. You don't want to overfit your knowledge, so you don't want to just memorize one example because if you're ever faced with something different, it'll fall over because variables haven't got the same names and you're not doing exactly the same function names and so on. So once I can memorize this and type this out from scratch and understand each piece, then I'll probably go on ChatGPT and just say, please modify this with different names. Once you can do it with different names, then you start to move on by slightly tweaking the function. So rather than just print, I might get it to do some kind of iteration or something, and maybe do a filter map or something a bit more advanced, a bit more real world. So yeah, that's how I'm attempting to learn it. I'll come down and I'll delete a block. I'll type it in. An hour later, I'll do the same if I've made a mistake. So I split this up into what I know already, the new parts, 1, 2, 3. So there's 3 things which are kind of new or specific to the adapter pattern. Once I can delete each of these sections and retype them in, then I'll try and implement them. And often, I said before, I'll learn the hard part, but then forget how to actually implement it. So that's equally important. Don't just learn the pattern and then not be able to implement it. Yeah, then paste this into ChatGPT, get it to change all the names just so that it looks a bit different. And then thirdly, actually change the function so that it's not just print. actually do something interesting with it. So yeah, maybe filter map or some sort of iteration, or with some sort of maybe a match statement or something sort of conditional in it rather than just a plain old print statement. But yeah, starts every step, every journey starts with 1,000 steps. Is that right? Thank you for watching. I'll be back soon. Cheers.